Hello everyone, welcome to the third experiment for digital logic design students. Today we will apply NAND and NOR and XOR gates. We will start with NAND gates, constructing this figure in our simulation software, which is Multisim. Similar to what we did in the previous labs, we will place a NAND gate. So again, go to all groups, search for NAND with 2 input, place one here and one here. Also we need one NAND gate with 4 inputs, and we need LED as your output. Let's say the blue one, and we need ground. Then let's connect the NAND gates. Another leg of your LED should be connected to the ground. Now your circuit is ready, so let's test it using this table. It says when all the switches are zeros, so we connect all of them to the ground. Then let's run it. You will see that the LED is not lighting, so the output is 0. Let's try the second case. It says that when switch 0 is 1 or D is 1. Let's see where is D. D is the input of the last NAND gate and the second NAND gate. So we will disconnect this wire, delete the wire, and delete this wire. We will need voltage source DC, voltage source DC power, and put it here. Connect the negative side of the voltage source to the ground, and connect the positive side to your input D. Then run it. Again, it's not working. You have to do the same for the rest. This one is 0. Let's try this one, the case before the last one. When A is 1 and B is 1 and C is 1, but when D is 0. Again, you will go back here, see where is A, B, C, D, and now you have to do the opposite. So you have to delete this wire, delete this wire, connect this one to the ground. This is D, and connect this one to the ground. Delete the others. Now connect them to the voltage source or the battery. Now let's run it. You can see that the blue light appears, so it's working. Then your output is 1. Let's do the last case when all are 1. Then run it. You see again it's working, so again your output is 1. Similar to that, you have to do the rest. After you finish filling this table, you have to do this kernel map and minimize the expression. This one also similar to what we did in the previous labs, but here we are using XOR gate. Again, right click, place component, search for XOR gate, and we just need LED, and we need ground. Also we need DC power. In the table it says when both are zeros, so we go here again and connect both inputs to the ground. Now let's run it. You'll see that the LED is not lighting, so your output is 0. Let's try the second one. When the first input is 0 but the second one is 1, so you'll disconnect the second wire and connect it to the battery. Connect the negative side of the battery to the ground, then run it. You will see that there is red light, so it means that it is working, so your output is 1. You have to do the rest. Then let's do figure 3.2. we need 4 different NAND gates. Now when both inputs are 0, so it means both inputs connected to the ground, you will see that the LED is not working, so you will put your output as 0. Let's try the second one when your first input is 0 and the second input is 1. So your A is 0 and B is 1. So we will need the DC power, so connect the positive side to here. Now you see that your LED is lighting, it means that your output is 1. Similar to that, you can do the rest. Now let's try figure 3.4. we need 4 different XOR gates. After you connect your LEDs with the output of your XOR gate, let's see, we have one common switch. It's called pulsar switch here from number 2 and 5 and 10 and 13. All are connected as one input called pulsar switch. So let's see our table. Here it says that this is your common switch, the pulsar one. it's either 0 or depressed as 1. So let's try when it is 0. Connect this one to the ground. Don't forget to put a ground for the LED. After you finish, then you will have only 4 inputs, and from the table you can see that there is 4 switches, switch number 0 and 1 and 2 and 3. Let's try when all of them are zeros. So connect all of them to the ground, then run it. You'll see that none of the LEDs working, so you put all as zeros. For this side, you will need only to change the common switch, which is this one, and connect it to the battery. To make it clear, let's use another ground. Then let's try the right side when the switch is depressed. So it means that your common switch, the pulsar, put it as 1, and connect the negative side of your battery to the ground, and connect the positive side to your common switch. Now I think it's done, so we can try that. You will see that all your LEDs are working. There is blue light. So now let's try this case when all the switches are 1 and your common switch is 0. Your common switch is connected to the ground. This is your common switch, and you have 4 different switches. Connect all of them to the voltage source and see if it's working or not. You will see that all of them is working. So here you will get 1 1 1 1. Now when the common switch is 1, it means here is 1. So again we will just disconnect this and connect it to the voltage. If you want, you can use another DC power source. Now run it. You'll see that your LEDs are not working. So again you will put 0 0 0 0. Let's do only this case. Now your common switch is connected to the ground. So again this wire should be connected to the ground, but your switches, switch number 3 and switch number 1 are 1. This one is 1, so this one should be connected to the ground, any ground. Here the switch is 1, so it's connected to a voltage source. Here should be again 0, so we should connect it to the ground. And this one is 1, it's connected to the battery. Now run it. You'll see LED number 2 and 4 is working. The second and the fourth one is working. This one is the second, and this one is your fourth one. It's working, but the rest are not working. Similar to that, you can do the rest and fill this table and solve these few questions. If you have any question, you can contact me. This is my email, and after you finish filling this Word file, please send it to me. Thank you for listening.